Deception has a critical role in our cyber enterprise protection portfolio starting now. We've really been negligent for, let's say, 60 years, whatever the number was quoted last time, not using deception at all. A bad guy, when he looks at a target, knows it's a real target and has no worries about it not really being the real one, or not. Makes it really easy if you're an attacker, right? But also, our deploying deception slows them down, right? They're used to be able to run through the front door, run to a host, run to a server, run out the door. Man, if you put tripwires all over the place, deceptive sensors, man, they gotta walk like this now. They're walking like that. So that's fundamentally that's where I'm going to go. And then I'm going to show you an enterprise class technology that's doing it. It's with TrapX, our deception grid technology. And then I'm going to show you the technology itself. You're going to want more when I'm done. I'm sorry. You'll have to either come get my card or drop a card. More than willing to share. I love the trip. I live in Virginia now. My family's still out on the island, so I'm up here pretty darn often. I think my car can just drive it on its own at this point. I'm pretty darn close to it. So thank you for allowing me to spend some time with you. I'm not going to waste much time here. We're going to talk about some fundamentals on the front side and move into it. Okay, so first of all, metrics in security, metrics in information assurance, they're tough, right? Absolute number is 1,226. Doesn't mean anything, right? Is it the number of detections, the number of failed logins? The number doesn't mean much. And then, of course, the opposite extreme, red, yellow, green, it's just not enough context to say what does it matter. What we end up doing more times than not is taking trends. Let's take some information over a longer period of time. If I can compare this month to the last 6 months, I can oftentimes say, maybe I'm heading in the right direction. You know, maybe if I do X and Y goes the wrong direction, sign is stop doing X. Right? So this is the type of thing that we usually end up doing metric-wise. And here are some trend information. Those of you who are students of our craft, probably familiar with the Verizon data breach incident report. This is a 10-year trend. It's pretty interesting information as far as I'm concerned because of the longevity. Any 1 year, but over time. What it largely says here on figure 13 is that bad guys are getting in very quickly. 90+% of the time in hours or days. That's what that red trend line at the top is. The blue line on the bottom is how often defenders detect it in hours or days. And it's about 20% of the time and staying pretty flat. Is this a good trend or a bad trend? Bad. It's a bad trend, right? You know, they're getting faster, we're not. And that space in between, that's scary. Right? That's CISO employment insurance necessary. Right? Because this is oftentimes described as nine months bad guys are in. Right? That's the gap. Right? Over here, the figure 14, I think it is. Yep. So that one says, hey, who finds out about the breach? All right? And what that says, the graphic takes a little while to look at, and I'm not going to take you through it. But what the graphic largely says is about 20% of the time, the organization that is breached finds the breach. About 50+% of the time, it's a third party or law enforcement. And you care about that because if you find your breach, like Anthem, they kind of got lucky and had database administrator saw themselves logged into a database they weren't logged into, so they kind of got lucky. Hey, we found it. Now you control information dissemination when you find it. That's really important if you want to, system employment insurance, right? So if someone tells you you've been breached, now you're sort of stepping to their toes. So you care about this. Again, a bad trend. Right? We're not finding it ourselves, and someone else is having to tell us ideas of trends. So now let's get, what if you don't have 10 years to make a plan, right? So let's go to a military-grade model, right? How many of you have heard of OODA before? All right, that's if you lived in near Miramar, if you lived in Virginia Beach with a bunch of jet fighters who stand at the bar and go like this, you'd hear of OODA, but it's observation, orientation, decision, action. It was written, patterns of conflict. Colonel Boyd is sometimes called the Boyd cycle. And basically it's a way for dog-fighting jet fighters to talk to each other after a dogfight about how did it go? Why did you go like this when I went like that? I didn't see, didn't get the observation, so therefore didn't get an orientation, made a bad decision, took a bad action. right? So what movie comes to mind when I start talking about this?
Top Gun.
Yeah, so Top Gun is a little bit of an example. So OODA was meant to allow rapid decision making, and the key here with OODA is it's not about going through the loop once. It's who goes through the loop continuously the fastest. And by the way, you see this in boxing too, right? Which boxer is the one going through the loop faster? The boxer moving forward or the boxer moving backwards? Who's going through the loop faster?
The guy going forward.
The guy going forward, right? He's deciding like, oh, he's about to go left, bam! Right? He's about to go right, bam! And the guy who's, he's getting pummeled, he doesn't do anything, but he has to get more space because of the cycle, making him crazy, right? So, OODA is not just a jet fighter thing. You do it when you cross the street, right? You look left, right, is there a car? No, orientation, look safe, decision, I'm going to start walking, right? You're doing this all the time. But it's an interesting way to sort of look at our cyber action. I did a presentation on this in 2003 at Pentagon, sort of analyzing our cyber OODAs. And did we suck then? Yes. Do we suck now?
Yes.
Yes, right? The quintessential Air Force example is they do all their observation on the network in San Antonio. They do all the orientation, what does it mean to me in Fort Meade, Maryland. They do all the decision about what's going to happen in Colorado Springs, Colorado, and then the action happens everywhere. Do you know how hard that is to make it go fast? That's really hard. Right now, I made that comparison because as a Marine Corps, I had it all under one roof. Now we're smaller, more nimble, but the Marines love to give it to the Air Force, right? So, so we had all the observation, orientation, decision, action was literally under one roof, and it helped us a lot. We got asked hey, why do you guys do so well? Well, if we're going to make something big happen, these four people go, yes, right? There's no video teleconference, there's no information sharing, and wait till it gets printed. No, we're all looking at the same thing. Go. So it's just an interesting model. So I'll tell you a story, Top Gun story. So I went to the Naval Academy. They called my class a Top Gun class because we were the first class to enter the Naval Academy after Top Gun came out. You can't believe what a great recruiting thing that was. But so I go off on a pre-summer trip, and I'm with a fighter aggressor squadron, basically a dogfighting squadron in Hawaii. It was a good trip. It was a good trip. Another story, right? Buy me a beer afterwards, or I'll buy you a beer afterwards. But a lot of fun out there. So I'm going up a two-seater dogfight. We're supposed to be attacking Navy ships that has Navy aviation defense, whatever. So I'm going to be in the back seat. What do you think I'm thinking, right? What do you think my call sign should be in this model? Come on, who knows the movie? Right? I'm thinking I'm going to be Goose, right? I'm going to be in the back seat. I'm going to save the pilots. I'm going to look over my shoulder and say, he's on your 6, break left, right? Or whatever the thing in the movie was. That's what I'm thinking when we're going to go up and do this thing, right? I've got this whole, I can practically hear the music. I still kind of get my blood going again. See me, whatever. But the reality was, we went up there for 2 hours. We got 3 different dogfights. Dogfights are amazingly quick. Frankly, they end pretty quickly. But you know what I saw? Like this. Not one enemy aircraft once. And the pilot I was flying with saw them all the time. Matter of fact, it's actually disturbing. You don't realize how trained you are in the car. When you're flying behind a dogfighting jet fighter, he never looks forward. He's always like this, right? He almost never looks forward because he's not worried about driving into a tree or whatever. He's just trying to know where the other guy is. He's got sort of unlimited three-dimensional space, so looking forward is sort of like, it was really disturbing to sit in the back seat and have the driver not looking forward. I didn't realize I had to bias, but I never saw anything. And why was I just dead weight? Because I never made the initial observation. I never saw him. It happened so quick. I was so untrained that literally, throughout this whole thing, I saw nothing. I'm going to make a connection that one of the reasons why that big gap we have between bad guys getting in quickly and us finding them very slowly is because we're not making an observation. Right? And why are we having a trouble? When an advanced attacker, APT, customized, whatever language you want to use, why don't we see that?
We don't know what to look for.
We don't know what to look for. They're not using yesterday's attack code. They're not using yesterday's attack code that's in your antivirus, right? And they're not going to go big and loud and cross some threshold of anomaly detection. They're smarter than that. Right? So we're having a problem because we're basing all of our defenses generally on pattern matching of one sort of fashion. Sometimes it's cool, machine learned signature. Or we're using anomaly detection, right? We're saying, okay, you crossed this threshold and that's bad. we humans are not very good at that. We're really irrational, right? So that's one of the premises. The reason I'm going through this, it's a little bit fun, it's late in the evening, got to use lots of pictures if you're going to do an evening talk. That's just the way it's got to be. All right, so one more simple model. All right, how many of you have heard of Win Schwartz's Time-Based Security? It's a great book to give to your boss if you're a security guy. Right? It just uses time as a basis of analyzing a security problem. It's relatively simplistic. Many people call it a bathroom book. It's pretty small. One flight from here to Philadelphia, maybe here to DC, you could reach. Right? It's timeless as far as I'm concerned, but basically it says this. The fundamental, simple, functional security model is this. Time protection works. Right? We'll use an example of a bank. Right? The time the money can stay in the safe, right, has to be greater than the time it takes you to detect that someone's trying to steal it, plus the time it takes you to respond and stop them. Right? I mean, this is pretty simple. This is not hard stuff. Right? And there's all kinds of things you can put in a protection bucket, all kinds of things you can put in the detection bucket, there's all kinds of things you can put in a response bucket. Right? And I'm not going to go too much deeper than this, but just to say, look at the model. So if looking at my numbers here, the bank vault is decided that it can retain 8 minutes of attack on it from underneath. And a bank detection takes 3 minutes. 3 minutes into the attack, the bank is aware the attack is underway. And it takes 4 minutes for the police to get there from that detection to stop or not stop. Who wins in this mathematical mental twist? The bank or the robber? The bank, right? Because the bank vault lasts 8 minutes and the attacker is caught in minute 7. Hey, I get it simple, right? But honestly, I find coming back to some of this sort of simple model has helped me do some very complex problems and break it down to something I can actually make actionable, right? So let me do this again. Same model. We can say, in this case, the model's broken, right? I'm not going to test you here, right? The bank vault still has 8 minutes of protection value to it, and the detection takes 5 minutes instead of 3, and the police still take 4. The police get there in the 9th minute, they're gone with the money, right? And what I'm saying here is that this is what the Verizon Data Breach Incident Response Report is saying, that our protection is working less time than the detection plus response. This is our fundamental problem. We're not detecting and responding such to stop the breach. And that's why I'm an OPM guy, right? I have security clearances for 30 years now, and they're all in China right now. There is nothing that's not in there, right? Every neighbor, every person who recommended me, every person they decided to talk to, regardless of who I told them or whatever, every credit card address I've ever had, it's all in there. I mean, you have a top secret clearance, it's like, open the kimono, right? I mean, and it's all gone, right? And so, fundamentally, I mean, it's just not working. And I'm saying all this to say, maybe there's something else, tried and true, that we haven't implemented in this space yet, right? I'm not trying to do some newfangled, advanced thing. I'm saying let's go back to basics, right? So I'm going to suggest. No, I'm sorry. Before I suggest, I'm going to make one more conclusion. So when you're going to fix this model, traditionally, what we try to do is try to make. Because what you want is you want this to be big, and each of these two to be small. That's great, right? You can make this 12 and make this 1 and 2. Phenomenal, right? So generally, historically, last 20 years, what we try to do when this gets broken, hey, make the wall bigger. Let's make protection. Let's add another safe outside the safe, right? Let's set up flame-throwing motion detectors or something, right? Let's make detection quicker. Let's put more sensors out there. We need bigger correlation. Like, I'm an ArcSight guy. Trust me, I understand that problem set, right? I had 20 terabytes of storage in 2003 for my problem. Make response quicker, pre-planned. These are traditional responses. And I'm going to suggest that there are some tools that we haven't used yet, primarily deception, that can make the targets more difficult to identify for the attacker. right? So sometimes I don't have to make protection last longer. I got to make the attacker move slower. They're about equivalent to each other, right? Mathematically, I understand. I mean, if the attacker is able to sprint in and sprint out, man, I got to get detection and response down like that. If I can make it go like this in, well, maybe my detection and response doesn't need a forklift 1,000% better performance. Maybe I can bounce things down a little bit, right? So that's what I'm trying to say. Obviously, I want my protection to work well, be quick, and last a long time. And I also want my attacker to have to move slow, right? That's good for me. So, old doctrine, thousands of years old, right? All warfare is based on deception, right? If you're far, and by the way, you see this. If your kids play basketball in your driveway, you see them doing this, right? They go right and juke left, go right. It's just very fundamental to us. And if I'm happy, if we're opposing wills at something, I'm going to try to make you think I'm going this way. I'm actually going to go that way, right? Because it helps me and slows you down, right? But we don't do this in cyber. I mean, let me quick question. Where do we use deception in cyber today?
Honeypots.
Honeypots. That is absolutely the quintessential answer. But why don't we do that at scale?
It's hard.
It's hard. It's hard. Hard to deploy. I mean, I'm an original honeypot, a HoneyNet project guy. Lance Spitzer and I, old friend. You look in the front of his first book, you're going to see my team. I was doing all classified stuff, so it couldn't be in the book. But you can reference my team to the work we did in the 90s in this area. And I then went to protect the whole Marine Corps, deployed not a single honeypot. Too hard to deploy, too hard to manage, too much work to forensically analyze. God forbid someone takes it over from me and uses it against me or against someone else. Right? I'm not going to go into what honeypots are, but fundamentally they're a setup victim. Right? I won't go too much further. So, cool thing is, Gartner seems to be picking up on this too. They're starting to use terms like deception in depth. And they're making some pretty strong statements. They're actually using the word offensive. I'm not going to go there, right? In the government side, you don't use offensive and cyber together because that gets you in trouble. And you got to be in the right agency and the right clothes to do that. But basically, using attackers' deception as a response strategy, game-changing effect, right? So it's kind of cool that they're seeing this. And fundamentally, the original honeypot concept still applies. It's just can we get around all those other problems? Right, so how does this work? I'm going to kind of quickly go through this and then get to a demo. Basically what we're doing is we're intermingling. We use the language malware traps. Right, you can call them honeypot 3.0. I don't really care what you call it. But basically we're intermingling fake IT assets amongst real IT assets. The key is they're not real, they're not full operating systems, not full applications, so they're not heavy, they're not takeoverable. They're actually emulations, and I'll show you a little bit more about that. But the way this works is the bad guy breaks in. We're using a little bit of the cyber kill chain, the Lockheed trademark thing, but basically the bad guy breaks in, takes over an IT asset, then he's trying to move on to the server space where he can find the critical information, where he bumps into our malware trap, attacks the malware trap. The automated analysis tells us exactly what the attack is he's using, 0-day or not, and allows us to be able to now understand what the attacker's doing. So now I'm going to show you the solution. 3 major components. I'm not going to go through them in depth. That's going to take a follow-on conversation because at times I feel like I'm pretty sure you guys got about 5 minutes left in you before you eyeballs close or whatever. So I'm gonna hit that timeline and we can stay all night if you want to keep going. 3 major components. Key thing is it can be all virtualized. It can be all on-premise or the vast majority in cloud. Your call, right? That's sort of critical. But the 3 components, the way they work together is this, right? This, what we call the TrapX appliance, this thing actually distributes automatically 2 radio buttons, Windows Server, 2 radio buttons, VoIP phone, 2 radio buttons, SCADA network, 2 buttons, Linux server. What services do you want running? Which version of Windows? You want to be an XP, SP2. You want to be a Windows Server 2008. 2 radio buttons deploy. 2 radio buttons deploy. Right? And so that easy to deploy. I forgot this reveal. So we're using sort of these green assets to be our malware traps. I like lots of them. They're so easy to deploy. There's no agent on any of your production systems. It costs you an IP address. That's it. You got IP addresses, deploy hundreds of these. Why have 1 tripwire in a house? Have hundreds. right? Idea-wise, we don't charge by those anyway. They're kind of unlimited emulation. So, bottom line, attacker breaks in. He gets into some workstation, some laptop, and he stakes his claim. And of course, first thing they're going to do is start moving laterally to try to find the important information. They usually get to a laptop. Some user clicks on something they shouldn't have, and now they want to get to a data store with patient healthcare information, credit card information, whatever. It's usually in a server VLAN or something like that. But they go ahead and they spread. So when they hit our malware trap, it automatically, so the cool thing is what we're doing is not only we have honeypots out there so we can detect that an attack has occurred, because we've already got a conviction at that point. But right inside the solution is a complete forensic solution and sandboxing solution. So this malware is automatically, no human intervention necessary, analyzed so you know exactly what you're dealing with up here. This report comes back, and now you can figure out where else they've already been, because there's a good chance that they didn't just hit your malware trap only, they probably hit some of your other IT assets, and they're starting to beacon and phone home. The automatic analysis, even if it's a zero-day command and control mechanism they're using, phoning home, giving that remote access, now that we have analyzed it on the internal sandbox, even this remote system here has been compromised. We also watch the outbound traffic and tell you, oh, here are other hosts. Automatically, the indicators are compromised and can then be shared to your ecosystem. That is the idea. So let me show you the solution. I'm about to get the hook. It's 2 minutes. I'm going to get the hook, and let me show you the live solution. If any of you are in the medical field, we just released an anatomy of attack, basically medical device hijacking devices. They're very easy to hack. They literally, with an IP packet, can kill someone. Right? These are intensive care devices. The report's cool. Just let me know. I'll send it to you. So let me show you the real solution. So this is the dashboard for our TrapX management console. Pretty simplistic, right? Because who should be talking to a fake asset? Nobody. Right? So we don't get the hundreds of thousands of events per second that I'm used to in the sim world. Once I whitelist the natural discovery tools, then everything that touches me is at least curious. It's at least a misconfigured application, might be a misconfigured person, or it's malware, polymorphic or otherwise. I don't need a signature. If it just touches me, then I'm going to show them my weaknesses and get them to attack me. And that's what I'm going to show you here. I'm just going to say, here's the dashboard, all these top 10 kinds of lists. This is actually a fairly, showing Russian activity in this case, but let me show you the depth of analysis here as well. So with one click, I'm now going into all of the automated forensic capability built into the product. That, again, your users, your system administrators are not going to have to be involved with automating, turning this on. I mean, when I first started playing with honeypots, it took me a week to do the analysis of one of my compromised systems. I had to all have the images and memory dumps and all this other stuff. Nowadays, all the virtualization, all the sandboxing technology, I can, with a click of a couple buttons, be able to tell you, all right, here is a binary that we captured. It's got 0 of 42 antivirus signatures, so this is a true 0 day. So what am I really looking at? Well, let me go into the sandbox and tell you exactly what we're looking at and show you how it's communicating, what communication mechanism. In this case, it was a port 80 communications, but basically show you all the analysis down to the command lines issue, the MD5 hashes, and you can then integrate it into your EPO. Hey, go find everything that has this DLL. Go find everything that has this registry setting. These are compromised systems, right? That's where I'm going to stop. I've been talking like a machine gun. You might give me a minute or two if you have a question.
One question.
Okay, so this is a two-parter. So one thing is you have to be constantly looking for these things, right? And how does that affect performance? That's the first part.
Constantly look. So once we go out there, we probably pretty much sit and wait for them to come to us.
Right, but you have to know that they're coming or that they've came, right? So you have to look at the traffic and analyze it as.
No, I'm not. See, I'm not watching traffic going through the network. That's the beauty of this, right? I go out there and I look like a real operating system with a real service, or a real VoIP phone, or a real SCADA system, whatever it is, right? And then I'm waiting for people to touch me. Right? If you represent a compromised host in the environment, the information that you wanted wasn't inside of you. It's actually inside the database server somewhere else. So you're going to start looking around you to find a system that has a database administrator's password on it or something like that. So you're going to start touching maybe a simple, a simple single packet, simple SIM packet. And if you represent my fake asset, the fact that you just send one packet over to see if you respond, I already know there's something curious happening, right? And I'm not expelling any resources waiting for that first packet. So I can deploy, we have yet to find a limitation on the number of emulations that we can run, period. Because once they're set, initially it's just whitelisting, okay, healthy network discovery tool, healthy network, EPO, rogue system detector, okay, whitelist that one, that should touch me every now and then, don't alert me. After that, I'm really just sitting listening. And when you talk to me, the first packet comes at me, I'm going to reply with vulnerable XP system. Or anything you want. Or I can put spin data in it and say, okay, system administrator password file. Right? I can reply with all kinds of SMB, activities, FTP, SSH stuff. Second part question?
Second part is, if there's anything slower than threat detection, it's threat response. Right? So how do you kind of help with that in terms of, do you make suggestions on what to do?
Sure, yeah. Well, we get the indicators compromised, right? So this is exactly, so once we take the malware, put it into the dynamic analysis tool, sandbox, whether it be Threat Tracker, Cuckoo, or McAfee's Advanced Threat Detection. We're not a sandbox. Palo Alto, FireEye, LastLine, we're going to use all of their sandbox. They're pretty good at it. Then we're going to feed it back to us. We have our own botnet detector to see communication. But if you're in an EPO, you're a McAfee shop, well, then it's automatically integrated to their system. So, hey, they've got agents are really good when you've got something valuable to look for. I don't want to be in the agent business. I hate putting agents on my systems. But I find valuable things to look for. Therefore, I love agents. Other people's agents. Right? And I love your ArcSight system. I don't want another 20 terabytes. But when I tell you, here's a system you want to know everyone has talked to in the last 2 weeks, I don't know that. But I do know that. That's one you need to know who had talked to everyone in the last 2 weeks. That's in your SIM. That's good for your Splunk system. They do that well. I don't want to do that. I'm going to give that to them. Open API, both directions.
Great, thanks.
You go here. We can ask one-on-one. So thank you very much.